everyone, this is Zahabiya Akhtar Shaikh. I'm student of MSc first year from Physics Department at MNU. Today I'm going to explain Newton-Raphson method. This is the method which is used to obtain the required solution for the nonlinear equations. There are different types of methods like false position method, secant method, but those methods take a lot of time, and Newton-Raphson method, its rate of convergence is very fast. It is a very great method to use for the required solution, to take out the required solution for the nonlinear equation, because the answer is obtained in very less iterations. So we will look it through the derivations and the example. So let's proceed with it. So first, beginning with the diagram that I have drawn here, this shows, first of all, the Newton-Raphson method is also known as the tangent method because the tangents are drawn. Let's see in detail how it is obtained. Here is a point, that is the P naught, which have the coordinates x naught and f of x naught. And here we have drawn a tangent. Through the tangent, we will give the coordinate which will form is x1 comma 0. And by doing such, by drawing the different tangents to the point like this, it will be x naught, or just suppose here we will get x2 comma 0. Like this, the rate of convergence will be very fast, and in very less iterations we will get the required solution. As it is based on tangents, so let's see the equation of tangent. The general equation is y minus y1 is equals to dy by dx x minus x1. Based on this equation of tangent, we will write another equation of tangent based on this diagram. So it will become y minus f of x naught, where in the place of y1 it will be f of x naught, because here it is x0. Suppose it's y0, so here it is f of x0, so f of x0 equals to f dash of x0 x minus x0. Next, here y is absent, so 0 minus f of x0 is equals to f dash of x0, and in place of x it will be x1 because we are taking for this, so x1 minus x0. Next, we will just change the places. Here it will be as it is, and minus f of x0, and this will go into the denominator, so it will be f dash of x0. Next, for we are taking for the x1, so it will become x0. Here it was negative, and here it will become the positive. Next, it will be minus f of x0 upon f dash of x, and this is the formula for Newton-Raphson method. So the general formula is x of n plus 1 is equals to xn minus f of xn upon f dash of xn. Here f dash of xn should not be equal to 0. This is a very important condition, because if it becomes 0, so definitely the solution, the formula won't exist, and it will not move forward. So this condition should be applied. And this is the main formula for Newton-Raphson method. Now we will see an example so it will be more clear to you all. So we have here the example, that is x is equals to root 12. So students can be asked the questions like to find the solution up to three significant digits or three decimal places. These two words will be common in the questions. So based on that, we have to find the required solution. So here we will be finding for the three significant digits. So let's proceed with the solution. So first of all, we will remove the root. So by applying it will become x square is equals to 12. Then we will proceed it to make an equation. So it will become x square minus 12 is equals to 0. Now we have to find its derivative with respect to x. So we will write f dash of x is equals to twice x. Now we have to put the values for x, and when the values will be negative and then positive, based on that which will be nearest to 0, we will take the value of x naught. So let's see, for f of 0 it will be 0 minus 12, which will give minus 12. This is negative. Then f of 1, which is equals to 1 minus 12, it will give minus 11. Then f of 2, it will be 2's square is 4 minus 12, it is equals to minus 8. Then for f of 3, it's minus 3. And for f of 4, it will be 4. So here we have got negative value and this positive value. But the nearest to the 0 is f of 3. The value of x is equals to 3. So we will take x naught is equals to 3 for our further solution. So let's begin with the first iteration. First of all, we will find the value of f of x, that is f of 3, and f dash of x, that is f dash of 3. So f of 3 will be 9 minus 12 is equals to minus 3. We have got it from here, like this f of x is equals to x square minus 12. So based on that, we have got this. Now for f dash of 3. So f dash of x is equals to twice x. So here it will be 2 into 3, which will give us 6. So these both are the values for f of 3 and f dash of 3. Next, we will compute it in the formula. So in this we will put it, so x 3 upon 6. So it will give us 3.5. You have to put these values in a calculator and you will get this answer. Now this value will become the x naught for the next iteration. So let's proceed further. Now we will put for 3.5, it will be 3.5 square minus 12, which is equals to 0.25. And for f dash, it will be 2 into 3.5, which will give 7. In this we will compute 3.5 minus 0.25 upon 7, and this will give us another value of x1, that is 3.4643, and this will again become the value of x naught for the further iteration. Now for the next value of x of 0, 2.4643, so f of x will be, now I'm doing it directly, this and this 46434 f dash will be 6.9286, and now we will compute it in the formula. It will be 3.4643 minus f of x, it is 0.0014 upon 6.9286, and it will give the value 3.4641. So this is the value of another solution. And if we look into the previous value of x1, that was 3.4643, and here now we have got 3.4641. So this up to 4 significant digits we have got the same, that is 3.464. Define the f of x for 3.4641, which is 3.4641 square minus 12. It approximately comes like minus 0.0000. As it has came to an end, the formula x1 is equals to x naught minus f upon f dash of x naught. So this value, if I put it this here, it will become 0, and ultimately the whole thing will become 0. The function has vanished, so we will stop it here, and the required solution will be 3.464. It is up to 4 significant digits, or you can say up to 3 decimal places, as the question has asked. Based on that we will give the answer. So here it is up to 4 significant digits, so we have got it saved in 2 iterations, simultaneous 2 iterations. So we have got the required solution, that is 3.464. So the value of root 12 up to 3 decimal places, or if the question is in the form up to 4 significant digits, the required solution is 3.464. As there are two types of methods to solve the nonlinear equations, to get the solution for nonlinear equations, there are direct method and there are iterative methods. This is one type of iteration method, and this is an easy one, but manually this becomes difficult, but these are very prominent for the computational purposes, for the coding purposes. I hope you all get a general idea about how to solve Newton-Raphson method, and how to get the required solution for nonlinear equations. Hope you got it. And thank you for today. And have a nice day.